everybody, welcome to Mad Science with Meg. Today we're going to do a lot of cool things. Most importantly, we're going to talk about rocks and why rocks are super cool. So if you have a rock collection, today's your lucky day. Pause this video, go out and get all of the rocks you have in your house. If you don't have any rocks in your house, maybe ask your grown-up and be like, hey, can we go outside and get like 3 rocks? Pause your video and do that, and I'll see you soon. Awesome, did you collect all your rocks? Now, if you've collected all your rocks, that's great. I've got another question for you. Yesterday I did a really cool video on shark teeth. Did you watch that one? Might be kind of interesting. Might want to pause this one and watch that one and then come back. But if you already saw my ultra cool shark tooth video, awesome, good for you. And settle in while we talk about rocks. There are 3 major different kinds of rocks. And these 3 rocks all differ based on how they're formed and the physical changes they go through. Now, you at home probably are like, I go through physical changes. You do. You grow taller. Your hair gets longer. If you're really old, you start to shrink. But these physical changes, obviously rocks aren't growing, but they go through their very own types of physical changes. And the physical changes they go through make them become, a sort of rock. An igneous, sedimentary, and a metamorphic. Before we start, I want to say, yes, there are some rocks that can be igneous and metamorphic. There are some rocks that can be sedimentary and igneous and then metamorphic. This is kind of a changing thing, but stick with me, you're gonna get it, I promise. So, do you have your rocks? Today we're gonna figure out what rocks you have at home are igneous, metamorphic, or sedimentary. The first kind of rock we're going to talk about today is the sedimentary rock. Have you been to the Grand Canyon? I haven't, I'll be honest with you. I've never been, one day maybe, but in the Grand Canyon, you can see where the land has eroded. Now, erosion just means that it's broken apart. So that land has broken apart and left these big rock structures. Those rock structures, if you look at them, you can see different colors and different layers. Grand Canyon, perfect example of a sedimentary rock. Sedimentary rocks are made when whoosh, wind carries rock dust away, breaks rock dust off of rocks. That rock dust combines with other rock dusts and some organic materials like leaves and gets squished together and combines. Now, my example is sandstone. You can see the sandstone has different colored layers. This is because it's been squished together of all sorts of different kinds of rocks. Now, the cool thing about sedimentary rocks is, depending where you live, if you're driving, maybe in Pennsylvania, driving along and you look out your window, you can see sedimentary rocks, and you can tell they're sedimentary rocks and identify them based on the layering. Or, kind of like this, you've got a bowl of vanilla ice cream. You pour tons of sprinkles in, rainbow sprinkles, mix it all together. You've got ice cream and rainbow sprinkles. But you can still see the rainbow sprinkles. Similar to a sedimentary rock where you can mix all sorts of rocks together. They'll dry and squeeze together and become one rock, but you'll still be able to see the little individual rocks. So, pause your video, look at your rocks, take your sedimentary rocks and make a pile of what you think your sedimentary rocks are. Look for the layering, that's key. All right, pause this and then come back when you're ready. Our second kind of rock is going to be the very fancy igneous rock. Now, I like igneous rocks a lot, mainly because I really like volcanoes. What about you? You guys all I'm a big fan of volcanoes. I'm hoping you are. Volcanoes are awesome. And they're fascinating because in the volcano, you have magma. Magma, magma, magma. That magma, immediately when it hits the Earth's crust and sprouts out of the volcano, we call lava. Now, when that lava cools down, it creates an igneous rock. But there's possibility that that magma inside the Earth is also cooling down, also creating igneous rock. Now, these two igneous rocks, you can kind of spot them by their grain shape. That's just talking about holes in these rocks. Some are gonna have huge holes, some of them are gonna have little holes and almost look like they're smooth. My example is, I have a blue obsidian stone here. Now, obsidian normally is deep black. Do you like obsidian stones, Otto? So obsidian stones are normally deep black. They're very smooth because this is when lava quickly cools down and dries. So it almost looks like they don't have any holes. But if you look in your house, maybe in your shower, in your bathtub, you'll see a pumice stone. They have holes. They're also igneous rock. They have holes, and they're used in homes to scrape away dead skin cells. Right, Otto? Scraping dead skin cells, scraping dead skin cells. Get out of here, dog. Yeah, he wants to help. He's a good little geologist, aren't you? You dig holes all the time? Is that what you do? Yeah. Maybe if you have a backyard, you can go dig a hole in your backyard. I'm sure Otto would love to help. Now, our third and final rock group is gonna be your metamorphic rock. Metamorphic rocks are really cool because if you think and hear the word metamorphic, there's another word it might remind you of. Metamorphosis. He's trying to eat my metamorphic rock. What is he doing? Is a metamorphosis. Now think about a caterpillar. Caterpillars go through a metamorphosis. What do they become? Butterflies. It's actually crazy. Start out as a little fellow, cocoon yourself up, and then turn into a butterfly. That's absolutely insane, and I don't think we talk about how cool it is enough. Now, metamorphic rocks, like a caterpillar turning into a butterfly, under extreme heat and pressure is when metamorphic rocks form. They start out as a sedimentary or an igneous, and they get squished and hot and put a lot of pressure on them, so then they turn into metamorphic rocks. My example of a metamorphic rock is I have some very shiny coal here that's had a lot of pressure and heat put down on it. You want to see? Otto likes this one too. And you can see a lot of pressure and a lot of heat squished together and transformed this. Now, another example is if you have a pencil, you're making a grocery list. What do you want? Hamburger helper, apples, I don't know what you eat for dinner, noodles. That graphite you're writing with started out as the element carbon. It went through a lot of heating and pressure and squishing to become graphite. The same thing happened with diamonds. They start out as carbon, we put pressure and heat on them, and they become diamonds. My metamorphic rock isn't a diamond, but I think it's just as pretty. Now, you can tell things are metamorphic rocks by very faint kind of layering and lines. They're going to be white lines or black lines. Or you can tell by the deep grays and blacks. If you have marble or slate in your home, you have your very own functioning metamorphic rock. Look at all your rocks and put them into your piles. Did you have one from each group? Are you not sure if you've identified your rocks correctly? Let me know in the comments what your favorite rock was, or have a grown-up help you snap a pic and put your rock that you're not sure what is in the comments, and I'll see if we can decipher it here at Mad Science. Have a great rest of your day, and party on. Keep doing science, keep asking questions, keep exploring, wash your hands, and be nice to your parents. I don't know if they really want to spend this much time with you, okay? All right, have a great rest of your day, guys.